Mars. Mars is the fourth planet from the Sun in our solar system and is commonly referred to as the red planet due to its reddish appearance in the sky. Mars has a thin atmosphere primarily composed of carbon dioxide and is much colder than Earth, with an average temperature of 80 degrees Fahrenheit 62 degrees Celsius. Mars has been of great interest to scientists and astronomers for many years due to its potential for past or present life, as well as its potential as a future destination for human exploration and even colonization. NASA and other space agencies have sent several robotic missions to Mars, including the Perseverance rover, which landed on Mars in February 2021, to search for signs of microbial life and study the planet's geology, climate, and atmosphere. There are also plans for future manned missions to Mars, which would require solving numerous technical challenges such as providing life support systems, developing suitable habitats, and protecting astronauts from the planet's harsh environment. Despite these challenges, Mars remains a compelling destination for exploration and the search for extraterrestrial life. Atmosphere. Mars. Mars has a thin atmosphere compared to Earth, with a surface pressure less than 1% of Earth's. The atmosphere of Mars is primarily composed of carbon dioxide, about 95%, with small amounts of nitrogen, argon, and oxygen. There are also trace amounts of methane, water vapor, and other gases. The atmospheric pressure on Mars varies depending on the season and location. During the Martian summer in the southern hemisphere, the atmosphere is denser due to the sublimation of carbon dioxide ice at the polar caps, which leads to increased atmospheric circulation and dust storms. The thin atmosphere and lack of a strong magnetic field on Mars mean that the planet is bombarded by solar radiation and cosmic rays, making it inhospitable to life as we know it. Despite the challenges posed by the Martian atmosphere, it is of great interest to scientists and researchers who study its composition and dynamics. Studying the Martian atmosphere can help us understand the planet's history and evolution, as well as provide insight into the potential habitability of the planet for future exploration and even colonization. Hydrology. Mars. The study of Mars hydrology, or the movement and distribution of water on the planet, has been an important focus of exploration and research. While Mars is a dry planet today, evidence suggests that liquid water may have existed on its surface in the past, and there may still be subsurface water in the form of ice. In recent years, several robotic missions to Mars have provided new insights into the planet's hydrology. The Mars Reconnaissance Orbiter (MRO), for example, has identified numerous features on the Martian surface that suggest a past presence of liquid water, such as dried-up river beds, ancient lake beds, and minerals that can only form in the presence of water. In addition, the Curiosity and Perseverance rovers have studied the composition of rocks and soils on Mars and found evidence of ancient lakes and rivers, as well as minerals that can only form in the presence of water. Scientists are also interested in studying the potential for subsurface water on Mars, which could provide a valuable resource for future human exploration and even colonization. The MRO has detected evidence of subsurface ice deposits in several regions on Mars, and the InSight lander is currently studying the planet's interior to better understand its composition and potential for water. Overall, while the hydrology of Mars is still not well understood, ongoing research and exploration missions are helping to unravel the mysteries of this fascinating planet. Mars orbit and rotation. Mars is a planet in our solar system that orbits around the Sun at an average distance of 142 million miles, 228 million kilometers. The time it takes for Mars to complete one orbit around the Sun is about 687 Earth days, or approximately 1.88 Earth years. Mars also rotates, or spins, on its axis, which is tilted at an angle of about 25 degrees relative to its orbit around the Sun. The length of a Martian day, or sol, is about 24 hours and 39 minutes, which is slightly longer than an Earth day. The combination of Mars' rotation and tilt leads to seasonal variations on the planet's surface. As Mars orbits the Sun, different parts of the planet receive varying amounts of sunlight, which affects the temperature and weather patterns. For example, during Martian winter, the polar regions can become covered in a layer of frozen carbon dioxide, or dry ice, while in Martian summer, the carbon dioxide can sublimate and create intense dust storms. Understanding the orbit and rotation of Mars is important for studying its geology, climate, and potential for supporting life. Human observation and exploration of Mars have been ongoing for decades, primarily through unmanned missions. However, there are plans to send humans to Mars in the near future, with some proposed missions aiming to establish a permanent human settlement on the planet. Currently, NASA's Mars exploration program is focused on studying the planet through robotic missions, including the Mars rovers, such as Curiosity and Perseverance, and orbiters, such as Mars Reconnaissance Orbiter and Mars Odyssey. These missions have provided valuable information about the planet's geology, atmosphere, and potential for habitability. In terms of future human missions, NASA is planning to send astronauts to Mars in the 2030s as part of its Artemis program, which aims to establish sustainable human presence on the Moon and eventually Mars. Private companies, such as SpaceX and Blue Origin, also have ambitious plans to send humans to Mars, with SpaceX targeting the mid-2020s for its first crewed mission to the Red Planet. Human observation and exploration of Mars present significant challenges due to the planet's distance from Earth, its harsh environment, and the physiological and psychological effects on human travelers. However, the potential scientific discoveries and advancements in space exploration make it an exciting and worthwhile endeavor. Robotic exploration of Mars has been ongoing for decades, and has provided a wealth of information about the planet's geology, atmosphere, and potential for life. NASA has been a major player in robotic exploration of Mars, with a series of missions that have included rovers, landers, and orbiters. Some of the most notable missions include the Mars Pathfinder mission, which landed the first rover, Sojourner, on Mars in 1997, and the Mars exploration rovers Spirit and Opportunity, which arrived on Mars in 2004 and operated for several years, greatly expanding our knowledge of the planet's geology and history. Currently, NASA's Mars rovers, Curiosity and Perseverance, are exploring the planet's surface, collecting samples and conducting experiments to better understand the planet's environment and potential for habitability. In addition to rovers, NASA also has several orbiters around Mars that are studying the planet's atmosphere, geology, and climate. Private companies, such as SpaceX, have also expressed interest in robotic exploration of Mars, with plans to send uncrewed missions to the planet to establish infrastructure and prepare for future human missions. Robotic exploration of Mars allows us to study the planet in detail without the risks and challenges of sending humans to the planet. These missions have provided valuable insights into Mars' past and present, and have laid the groundwork for future human exploration and potentially even colonization of the planet. The search for life on Mars is a fascinating and ongoing area of research. One of the key factors in determining whether life could exist on Mars is its habitability. Habitability refers to the conditions necessary for life to exist, such as the presence of liquid water, a stable atmosphere, and suitable temperatures. Mars has been a prime candidate for the search for life because it is a rocky planet with a similar history to Earth. The planet also has evidence of past water on its surface, including dried-up riverbeds and mineral deposits that suggest the presence of ancient lakes or oceans. However, while the presence of liquid water is a crucial factor for habitability, it is not the only one. Mars has a thin atmosphere, with very little protection from radiation from the sun and other sources, which makes it challenging for life to thrive. The temperature on Mars is also much colder than Earth, and its surface is exposed to harsh winds and dust storms. Despite these challenges, scientists are continuing to search for evidence of life on Mars. Recent missions, such as the Mars Curiosity rover and the Mars 2020 mission, have explored the planet's surface and collected samples that could provide clues about its habitability and potential for life. In addition to exploring the planet's surface, scientists are also studying Mars' subsurface, where conditions may be more suitable for life to exist. The discovery of underground lakes and the possibility of geothermal activity on Mars has raised the prospect of microbial life existing beneath the planet's surface. Overall, the search for life on Mars is a complex and ongoing process that requires a multidisciplinary approach. While the planet's habitability may pose challenges, it is also a prime target for exploration and the search for extraterrestrial life. To get more informational videos like this, please subscribe our channel, share and press the bell icon. Thanks for watching.